So hi everyone, my name is Fraser Kane. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, May 10th. Post. There she is. All right. Let's hope that didn't break anything. So we've got Dave joining us this week. We've got Dave Dickinson.
Hey.
We've got Nancy Atkinson. There she is. We've got now the unnamed Nicole Gallucci. There she's back.
Look, it's back. It's purple.
It's back. It's
me.
back. And, Dr. Nicole Gallucci. And we've got Dr. Pamela Gay. So we've got a bunch of stories to talk about this week, and we've also got sort of a big breaking story that's going on right now, which is a coolant leak on the International Space Station that appears to be a little more serious than originally suspected. We've got sort of an update on the annular solar eclipse that just happened yesterday, an update on a gamma ray burst that's been observed by amateurs, the upcoming conjunction that we'll be able to see, a recent launch from a Vega rocket with a bunch of satellites, white dwarfs with planet pollution, and new observations of hydrogen clouds between galaxies. So. Well, let's start with the sort of breaking news right now, and I think Nancy,
Comments.
you've been.
Comments.
Oh yeah, the comments, of course. Whew. So many things to think about. Okay, so if you want to join the conversation, you can do that. And so all you need to do is just make a comment anywhere on Google+. There's a bunch of places you can do this. You can comment on the event page, so we'll be able to spot your comments there. If you're watching this sort of on Nicole's stream or on the CosmoQuest stream or on my stream, you can post a comment there. If you're watching this embedded somewhere and you like to use Twitter, you can use the hashtag Space Hangout. And the kind of the safest place is to make your comment over on YouTube. So if you're watching this anywhere, click on the little watch this on YouTube link, and then you'll go to YouTube, and then there'll be a bunch of comments there, and that will sort of pretty safely make sure that we're able to see your comments. So, and we'll be watching those comments and adding your questions and comments and feedback as we go through the show. So, all right. So, Nancy, can you give us an update on what is going on with the International Space Station?
Yesterday morning, the crew noticed some white flakes of stuff coming off of the station, and in particular the P6 truss area. And so NASA quickly got all the cameras pointed at that area and everything, and so they determined it's likely an ammonia leak, and ammonia is used for a coolant. All the solar arrays, and there's the power is converted to, or the sun's power is converted to electricity, and basically this all needs to be cooled off. And the power is there's 8 different power channels that take all the energy from the sun and distribute it among the different space station. Everything that's running the space station, running the experiments, everything like that. And anyway, one of them is leaking, and although they don't know it for sure, they think it's one of the pump and flow control systems for the solar arrays that's leaking. It was a problem actually for a couple of years. It was first a very small leak was noticed back in 2007, and just back in this past fall, there was an EVA to go out and fix that, and 2 astronauts did go out and they did some replacements of parts and exchanging out of various pieces, and it seemed to be fixed. But now all of a sudden, they noticed this huge leak yesterday. So while the crew is not in danger, it's the space station really needs the power. They can't go without everything working fine for a long time. They can do it for a while. They have diverted all the power from this one channel over to other channels and kind of spread it all out. But for the long term, they do need to get this fixed. So anyway, the mission management team met today, and they should be reporting in about an hour whether they're actually going to do a spacewalk tomorrow. If they do, it'll be Chris Cassidy and Tom Marshmerd going out, and as kind of a serendipitous occurrence, those two have been out on this exact area of the space station before, back in the SDS-127 mission. They worked together on 2 spacewalks going to about this same area. They didn't actually work on this pump system, but they replaced batteries in that area. So, but this is actually one of what NASA calls the Big 12 spacewalks, which is a group of spacewalks that everybody, all the astronauts that go to the space station, train for, because they know that it's a potential issue or something that that they'll need to address, possibly. So the astronauts need to be ready to do this at any time. And at the same time that the astronauts are getting ready to possibly do this spacewalk tomorrow, there's astronauts in the neutral buoyancy lab at Johnson Space Center going through the exact procedures and figuring out if there's any potential issues or that kind of thing. So, like I said, in about an hour, NASA will have a news conference to say for sure whether or not they will do the spacewalk tomorrow to fix that. And they that Monday.
I think that's going off at 4 p.m. Eastern time. Yeah.
Yeah. So I guess I don't know if there continues to be a problem, if their departure would be delayed at all. But anyway, it's kind of an interesting situation. It's exciting. Chris
Nancy's in space.
She's totally in space.
That may shuffle up the Soyuz return too. The Commander Hetfield's return also.
Oh, okay.
That's right. Yeah, Commander Hatfield is due to come home just in a couple of days. So
I think everyone's happy for him, but kind of sad
because he's so good.
Yeah.
He
like,
is...
yeah, you're coming home, but we're really enjoying that.
Yeah. I mean, I don't know. I was sharing that video there. I mean, you could really see the just pieces of coolant just floating away from the station.
It's snowing in space.
Yeah, it was like it was snowing, and that's a bad thing. You do not want to see anything coming off the station.
There was an outstanding documentary on the nature of things that I actually watched online on Commander Hetfield's time in space there. The man who tweeted from space. That was very good.
My buddy Ulysses comments that, ironically, there was a space station disaster film trailer released today as well. So there you go.
I would show it, and it's awesome.
But you would get me in trouble with the copyright.
But then you would get a copyright violation.
Go watch the trailer for Gravity.
So it's called Gravity, and just do a search for it and watch it, and it's like, the International Space Station getting sliced up and astronauts flying free. It's terrifying. So, yeah. Definitely want to watch it. Okay, well, let's move on. So I guess we're going to, I hope next week we'll have a more comprehensive sort of understanding of what it is that went on and what people have been doing about it. And, yeah.
This may be an issue, too. The ISS is reaching that time of year where it's going to be in full daylight. Right around the solstice, we usually get to that point where the ISS is in full daylight. I was just thinking that coolant may be an issue.
Yeah, no, coolant is important.
Yeah, if they're in the sun all the time, they definitely need to cool down.
Yeah. All right, well, let's move on. So there was an annular solar eclipse yesterday in Australia. So.
Yeah, yesterday, this morning, actually. It crossed the international date line, so the timing on this was kind of tricky. So it actually, on universal time, it started on May 9th, but on Australian time, it was actually early this morning on May 10th. It was interesting that this annular eclipse it crossed over Australia, but it almost seemed to try to avoid all the major cities of Australia. Now, all of Australia saw the partial eclipse, but the antumbra of the moon went over the Great Sandy Desert, over Northern Territories, and then over the Cape York Peninsula, which is some very wild, remote areas of the Australian bush. So people that did get photos, like this one up front on that was Jeff Sims, he actually had to go to a place called the Plutonic Gold Mine out in the it's a great name for a place, by the way, out in the Great Sandy Desert to get this photo of the eclipse rising. And it's interesting, you can see the atmospheric distortion of the, it's kind of an egg shape.
Sorry, Mr. Fraser. Can you put it back up for a sec?
Maybe.
I'm doing all the things at once.
He's got more photos coming, too. That was one of the very first. It was interesting watching the SLU broadcast and a lot of the other broadcasts. There was some huge connectivity problems. You could tell how remote this location for this eclipse was because there wasn't a lot of images coming out immediately. And even now, today, I'm still seeing people that have returned back to civilization that are just sending their pictures out now. As I was putting up that post this morning, I was getting photos from people as I was getting ready to put that up, and it was over 12 hours later.
Wow.
So, yeah.
Yeah, that was great. That was
Australia actually isn't going to get, it's weird, they had a total solar eclipse last November, which crisscrossed the path of annularity for this eclipse, and they're not going to get another total solar eclipse until 2028. So they're not going to get another one for a while.
They have an unfortunate location with the Saros cycle because what we see is the different solar eclipse paths repeat on a regular basis, and as they repeat, they migrate across the planet both in latitude and longitude, and so you'll get the exact same path recurring. And Australia is one of the edges of the Saros cycle because of its southerly location.
Yeah, the last one on this Saros was in 96, I believe it was, and that was over South America. It rotates about 120 degrees of longitude for each Saros. So we're going to see one finally. We're going to come out of our total solar eclipse drought in 2017. We were talking before the broadcast started of everyone's already making their plans of where they're going to be in 2017.
I'm just driving 30 minutes south, and there's totality.
Yeah, I've got about a 4-hour drive into Oregon, and then I'll be able to see it. Well, maybe a 6-hour drive, but
I think
we're totally doing it.
I think Columbia, South Carolina is where I'm heading. But although out west, you're probably going to have a better chance for clear skies.
I mean, just to be safe, I mean, I could make it sooner, but I think I'd like to head to Eastern Oregon, and then that will be sort of, chances are it's going to be a lot drier and clearer, I hope.
There is a hybrid. There is one more solar eclipse this year. This year is actually kind of an off year for eclipses. There's only 5. There was a partial lunar eclipse we had beginning this cycle 2 weeks ago. And then there was this one, and there's 2 more penumbrals, which are going to be very, very faint, like almost not even their eclipses, lunar eclipses. Then there's going to be a hybrid solar eclipse on November 3rd, 2013, into this year.
And hybrid is where part of the path it's total and part of the path it's annular.
Yeah. We're going to see from Florida here. We're going to see maybe a 2% partial rising that morning. I may try to get some images of that. We actually get to see a little slice of that eclipse. We're not going to see the totality, unfortunately.
We had a question about the previous story. If we can get to that quickly. It popped up and then disappeared, but it was somebody on YouTube, I think it was Hanno, asked if the ISS is always in the sun, how does it cool off?
Not always. It depends on the orbit. The orbital alignment is tilted about 52 degrees in inclination. So certain times of year, it's in the sun for the entire period for several days, and then it starts going back into orbital sunsets and sunrise. It's usually right around the solstice. It gets there's a season where the ISS is in the sun permanently for a couple days.
There's a great animation that NASA released from those wonderful time lapses that they've been doing, and there's a great animation where you can see the sun just going down just below the horizon of the Earth, and then it comes back up again, and so it just like it hangs in the sky, and so the station is just constantly in sunlight.
What's cool, if you're around 45 degrees, 50 degrees north or south, you can see 4 or 5 ISS passes, like from UK. They can see 4 or 5 ISS passes in one night because it comes right up overhead.
All right, well, let's move on with another story, and I think we'll go with Pamela, and we're going to talk about white dwarf, planet-polluted white dwarfs.
Right, so this was one of those stories that was like, oh, that's a great way to do an experiment that the universe did for us. Because one of the frustrating things that we deal with is it's not like we can go out and grab a chunk of an extrasolar planet and see what other planets are made of. We can't even get to Mars right now to do that. our solar system's benevolent enough that it hurls chunks of Mars at us for us to sample, but alien worlds are a bit harder. Well, it turned out that some scientists who were looking at a run-of-the-mill white dwarf star in the Hyades cluster noticed that it didn't look as run-of-the-mill as they expected. Normally, when you look at a white dwarf, these are extremely hot, little tiny embers left over from a star that has died one way or another. And when you look at them, because they're so hot, all of the atoms in their atmosphere have ionized, and there aren't any spectral lines. So you just see continual rainbow of colors. Well, when they looked at this particular white dwarf, instead of seeing that smooth continuum devoid of any lines, they saw lines that corresponded to silicas, lines that corresponded to amounts of carbon, things that they didn't expect, but they were able to explain as asteroids and other chunky debris left over from planets meeting a rather brutal end were falling into this white dwarf. So this is actually sort of what we do if we had a chunk of planet on Earth. We'd heat it up, look to see what atoms were in the process, and in this case, the white dwarf is heating up the chunks for us, allowing us to see what atoms are in the chunk, and so we're able to spectrographically sample extrasolar planets dying a suicidal death on the surface of their remnant of a star.
Very cool.
And what's kind of awesome about this is it's in the Hyades cluster. So this is a star cluster that's only about 625 million years old. So the planets that are dying are not ones that probably could have in any rational way supported any form of civilization. So we're looking at suicidal planets that probably weren't hosts of civilization, so we can celebrate the death of these worlds.
In that the cluster itself is not very old, and so the stars were probably a lot more massive, and so they lived fairly short, young, angry lives, and they just beat up their planets for the entire lifetime and then killed them. Yes, exactly. Right, okay.
And now they're eating the chunks.
Right. But, I mean, is this sort of a, this is the Hyades cluster. Is this sort of a bit of a sort of gruesome future for the kind of fate that might hit the sun and the,
no, because our sun is smaller. So the type of star that's going to have had a chance to live, die, and become a white dwarf in 625 million years, it's just what you said. This is a massive star. Now, with massive stars, they constantly emit large amounts of mass through stellar winds. They're blasting their planets the entire time, and the star probably died as some sort of a supernova. Now, in our own solar system, when our sun dies, it's going to blow it up into a red giant star, and then that atmosphere over time is going to end up just drifting away as the core collapses into a white dwarf. This still isn't a good process for the planet Earth, because when the sun blows up into a red giant, it's going to blow it up almost to the edge of our planet. And so we are going to get roasted. The sun is going to put the planet Earth on broil. But this is different from blasting us with massive amounts of stellar winds and then going supernova all over our planet. So we'll have a gentler, albeit hot, toasting death.
Right. Okay, good. It's good to know the way the universe is trying to kill us.
I want to see a star that spews forth maths.
Maths.
I just pictured equations coming out of a star, like
XKC, if it's gonna come from anywhere.
That's right. Get on that, Monroe.
What is with our internet today?
I don't know. We're all having slow.
We're all not doing so well. Okay, well, you know what, Nicole, it's up to you now to talk about how interesting radio astronomy is and what new discovery has been made. And I've got your picture here, so.
Sweet! I have a video too. So, the Green Bank Telescope, one of my favorite places in the world in West Virginia, was recently used to map some hydrogen clouds coming around the Andromeda Galaxy. So we have our galaxy and the Andromeda Galaxy, which are these two big spirals that are kind of the dominant features of our local group of galaxies. And so here, this blue swirly thing is not really Andromeda, but showing where Andromeda would be. And the red puppy things are hydrogen gas clouds. Now, hydrogen is the stuff that makes up most of the universe, and when it's in a neutral hydrogen state, it's fairly easy to see with a radio telescope. It gives off a spectral line at 1.4 gigahertz. And that is used to map the rotations of galaxies, the movement of gas clouds outside of galaxies. Now, in this case, they had seen some fluffy gas cloud bits before in the local group, and so weren't sure, was it raining? Some of it may have been raining down on the disk, some of it may have just been floating around. But these in particular, this I can try and show you the video that they put together. Oh, you do? Mm-hmm. Awesome sauce.
I hope.
Okay, so Fraser's playing the video, and so you've got the old data shows this squishy red stuff, but with higher resolution mapping, these are actually discrete clumps. These are discrete clumps of gas, of cloud. Now, but there's no stars there, right? So it's not dense enough to be forming stars. But it is dense enough to make it look like it's maybe a dwarf galaxy without stars. This maybe hints of these dark dwarf galaxies that just have dark matter and gas but actually never form stars. This is a problem in our current cosmological picture, is like there should be a lot more dwarf galaxies around that we don't see. So this is a hint that maybe we're seeing something else that exists in the local group, doesn't have stars in it, has this hydrogen gas that has been first seen with the Green Bank telescope.
So, I mean, as you said, this doesn't necessarily account for like massive amounts of missing maths in the universe.
This is not a massive amount of mass that's been missing. Like I said, they've seen this gas before, but to see that it is discretely clumped is kind of the new thing. And
do you think that, I mean, you know, this isn't forming a star, but could you get these kind of really sort of distant star clouds that could just gather enough material to form some sad, lonely star out in the middle of the universe, a galaxy on its own?
Well, this is these first condensations of gas in these dark matter halos probably what formed the first galaxies. But for some reason, this doesn't have enough gas or dense enough gas to be doing that. But sure, there are still dwarf galaxies that are making that have little pockets of star formation going on.
That's really cool. Okay, cool. So, right, we're going to talk about, with David, we're going to talk about an upcoming conjunction.
Junction.
I know.
Okay, how to do it.
We're finally getting some planets back in the evening sky right now. Everything is in the direction of the sun except Saturn right now. I've been following Venus coming up in the western horizon. You can just see it with the naked eye. With binoculars, it's pretty easy to pick out too. Tonight, it's going to be joined by the very thin crescent moon 24 hours after that annular eclipse. So I'll be out watching for that. And Jupiter and Mercury will be joining the show right around May 26th, 27th. We're going to have a triple conjunction where all three planets are going to be low to the west. Mercury is actually going to be occulted by the sun tomorrow, which of course nobody will see. But it's actually passing behind the sun and coming back out around. It's unfortunately it's not passing around from the front, where we'd see a transit of Mercury, but we won't. But Mercury is going to be joining with the pair. Venus is going to be the easiest one to sight. Jupiter is up higher right now, and it's going to be getting lower every evening toward the end of the month, and it's going to be joining in with Venus. And Aldebaran won't be too far away, and M45, you get really dark skies, you'll see the Pleiades. So there's a lot of action low in the western sky right now this month. That's really where to look.
It's going to be nice. I mean, it's a shame that it's fairly low, because, I mean, these turn into just wonderful pictures when you get that crescent moon, Jupiter and Venus really close together. Was it about this time last year or so that we were having that same sort of configuration?
Yeah,
but it was a lot higher, and Venus and Jupiter were really close, and people were just going crazy. I was watching Twitter, and I just put in a Twitter search for bright stars or two stars, and people, it was amazing to see how many people who had no interest in astronomy were noticing this configuration, and they were like, how come I never noticed those bright stars beside the moon before, and things like that, right? And like, obviously because the sky's moving around and things are changing, but
back in 2009, there was actually a very brief, what we call the smiley face conjunction, where there was a crescent moon below Jupiter and Venus. And me and a friend of mine did research on this. I mean, this is what we do for fun. And we looked up, and there's not going to be another smiley face conjunction until around 2060 or so. The orientation is not going to be quite right, where you have a crescent moon next to two bright objects like that, to have that kind of emoticon-looking conjunction.
I think the other
I
super
get questions
interesting
from people too, the same thing.
Yeah, but it's just great to see that these people, it never occurs to them, that they've never seen this before, because it's, very, very rare and really amazing. And yeah, anyway, so what I do is I go on Twitter and I just explain it to all of them.
Yeah.
You're on Twitter?
Until Twitter bans you.
Until Twitter bans me. So usually what I'll do is I'll go until Twitter won't let me answer this anymore.
Oh, Twitter jail.
Yeah. So it takes about 1,000 times that before I get caught.
Awesome.
Those aren't stars.
Good job.
Yeah.
You can see Venus. You can see Venus in the daytime if you know exactly where to look for it. Right? Not about now is not a good time to look for it, but when it's at greatest elongation from the sun, and if you have the moon next to it, Venus intrinsically is actually brighter than the moon. If you think of the actual square arc seconds of Venus, are actually intrinsically brighter than the surface of the moon. So it's actually a little. I show people Venus in the daytime whenever I can, and once you know where to look for it, it's actually pretty easy to find.
It's the knowing where to look for it part.
The moon helps. If the moon
And
is next
it
door,
moves, and the moon moves, and so you have to constantly look up where to look.
I have seen Jupiter during the daytime in Sirius as well, but those are very difficult.
Wow.
Daytime planet hunting is another weird hobby of mine.
Okay, so there was a recent rocket launch, Nancy, the Vega rocket. Oh, you're muted, Nancy.
All right. I didn't. You seriously wanted me to talk about this?
Just for a second, you can.
Okay, the European Space Agency launched a rocket on what day was that? Tuesday, Monday night, Tuesday.
I was watching that.
Yeah. David, you could probably say more. Anywhere there were 3 satellites on board. Two kind of Earth observing satellites, and one was a CubeSat. It was the second launch of the Vega. The new version of the Vega rocket, and everything went well, and I think all the satellites are working really as expected. David, do you have anything more?
I thought it was unusual they launched out of French Guiana into a sun-synchronous orbit, meaning that it was actually a retrograde, almost polar orbit. It was like an inclination of like 4 degrees off polar. Because when I saw that, I started doing some calculations. I was like, I wonder if we're going to see that come up over from South America. Unfortunately, we didn't, but it did come up over Bermuda and up over Nova Scotia as it was coming up over. They probably have launched that way out of French Guiana, but I don't recall it in recent memory. Usually they go for a low inclination orbit. So I thought that was kind of interesting.
And I think we have a question. There was a question that came from Beth Johnson. Is that the one you were talking about, Nicole? Yeah.
Yeah, there's a couple. They keep showing up and then disappearing from my stream, which is odd. But yes, we have a question from Beth Johnson on YouTube asking about the hydrogen gas cloud story and if this is different from ultra-compact dwarfs. Now, I think ultra-compact dwarfs are luminous. They have lots of starlight. There is lumiноusness of the dwarf galaxies, but they're just really dense. And I've seen them compared morphologically more to globular clusters. So I don't think that's what's happening here.
Dwarf galaxies, this was actually the topic of my master's thesis, was one particular dwarf galaxy. Dwarf galaxies, they have a completely different formation mechanism than globular clusters. Globular clusters form as part of a galaxy and do not have intrinsically a lot of dark matter, do not intrinsically have leftover hydrogen. Dwarf galaxies are galaxies that form by themselves, often end up in the halos of galaxies like ours, but have their own composition. And one of the really awesome things about them that causes people to think about globular clusters is the smallest of them are so small that it only takes one epoch of star formation before they run out of star-forming materials. But what's kind of awesome about the dwarfs is they have a ungodly amount of dark matter. They have a dark matter to luminous matter ratio that nothing else has. They're like dark matter, dark matter, dark matter. And then when you look at them in hydrogen gas, they're also rich in diffuse lobes of hydrogen gas that got blasted out during that initial phase of star formation. I will shut up now.
No, yeah, this question was about dwarf galaxies and whether they were similar to the ultra-compact dwarf galaxies, which is a separate issue from globular clusters.
Yeah, they're different.
Yeah. Ultra-compact dwarf galaxies are not the same thing as the hydrogen gas clouds. Neither are globular clusters. I was making a comparison. So that's one question. And then Jeff Borst is asking about dark galaxy. Have there been any other hints of these in observations elsewhere? And there are some very ultra-faint dwarf galaxies that have been discovered by Keck observations, I think, which are, again, like Pamela said, really hugely dark matter dominated, very little stars and star formation. I don't think these hydrogen gas clouds that they just discovered are quite on their way to being a dwarf galaxy, a dark dwarf galaxy of its own. I think they're more like clumps along a filament. But it's definitely not just gas that's been spewed out from the bigger galaxies and interactions. It seems to be its own entity. So not the same as ultra-compact dwarfs, not like globular clusters at all, but there is other evidence of these dark, very dark dwarf galaxies existing that may solve that dwarf galaxy problem.
All right, so I think our last story of this week is going to be this gamma ray burst afterglow that was observed by an amateur astronomer. David, you've got this story.
Yeah, we talked last week about gamma ray burst 130427A that went off in April. It was one of the most energetic bursts that was ever observed by the Fermi and Swift satellites. And I found out earlier this week when I was on, I'm periodically on the AVSO, the American Association of Variable Star Observers site. I found out that there was an amateur that actually managed to catch the afterglow of this burst. Patrick Wiggins from his observatory in Toole, Utah, got the alert that morning when it went off, and he managed to get a series of images and get a pretty good light curve off it too. He caught it right around 12th magnitude and tracked it into the sun early that morning and down to about 17th magnitude. And it's interesting that we were talking about last week what that might have peaked at in visual magnitude. There is the Raptor array down in Los Alamos in New Mexico that's run by the Los Alamos National Laboratory. That tracks gamma ray bursts as well. I'd never heard of this array before, but it actually triggered a few seconds before Swift did. It happened to be looking in the right direction, and they think the optical counterpart flow to this burst was about 7th magnitude, which would put it the second brightest gamma ray burst visually ever. I mean, if you had binoculars and you were looking in that direction in Leo toward the border of Leo and Ursa Major, you would have seen it.
Wow.
That would have been too cool.
That would have been cool.
I don't know, and I always wonder if there was some amateurs that might have been doing some surreptitious imaging around that area that might have caught it. I haven't heard anybody else saying that they had caught that visually. Matter of fact, Patrick Wiggins, when I talked to him, he said at first when he started imaging, he thought it was a hot pixel or something in his frame because it was so bright. He thought at first that it's like, I'm not actually imaging the gamma ray burst until he tracked it for a bit and checked it, but he actually did catch it.
That's really interesting. I mean, how long would one of those bursts be visible for in the sky?
This one, I believe they said, was 2.5 hours long. The outburst, this long gamma ray burst. On the light curve, looking at it, he tracked it for a couple hours.
That's pretty long, though, isn't it? 2.5 hours is for a visible burst. So the issue is,
where does it start on the scale? So if it has a constant losing n magnitudes per hour, if it starts at magnitude 6, you're going to get it for a couple of hours. If it starts at magnitude 9, you're toasted quickly.
Looking at his light curve, he has it starting off just above 13, and 2.5 hours later it dropped down to almost 16. So about 3 drops in magnitude. So it dropped, that's about 15 to 20 times in brightness, I believe.
Right.
Doing the math in my head. So, because it's logarithmic, each magnitude is 2.516 times 2.516. But yeah, that's a pretty cool catch. There's amateurs out there. I know a few people that are actively tracking follow-ups for gamma ray bursts. and they get these alerts, and then they swing into action and try to image them. So that was pretty cool.
That's really amazing.
There's the Gamma Ray Burst Observing Network run out of Sonoma State University, and the AVSO, which works with the folks at Sonoma, and that's a great way to get involved in learning how to observe these things and then submitting your data.
And he had a 14-inch Celestron he did this with an SBIG ST10XME camera, and it happened to be his birthday when he caught it. So it was pretty cool.
Aw, happy birthday!
Happy birthday!
From the
star,
universe.
a very large star, was destroyed in your honor.
I'm in favor of that.
Yeah.
Hugo Burnham asks adds us amateur astronomers make up part of the largest telescope on Earth.
Pretty much.
You do.
Pretty much.
Yay!
Yay. All right, well, I think that's all the big stories that we have. It's funny, last week it was just so many stories. We ran out of time, but this time I think we've actually run out of big stories. So I think we'll start to wrap things up. So where can we find out more about David?
I am on AstroGuys with a Z. I am on Listosaur, frequent contributor there. I'm on Universe Today, of course, Canada.com, and I am about the Orion Spur, our Milky Way galaxy, planet Earth.
Awesome. And Nancy, where can we find out more of your work?
Universe Today and the NASA Lunar Science Institute podcast, and Nancy_A at Twitter.
Sweet. Dr. Nicole Gallucci.
I need to have a TARDIS every time you say that.
Doctor.
I will in my office soon.
Isn't this week the Neil Gaiman episode? I'm just totally geeking out here. Neil Gaiman's written another Doctor Who episode.
Oh, this week?
The
I think
second
it's
one?
this weekend. Yeah, it's about the Cybermen. So anyway.
Oh,
Okay,
awesome.
very excited.
Yeah.
Happy squeak. So I'm not that kind of doctor, unfortunately. But I am actually going to my own graduation next week. So finally, from last August. Yay. But yeah, I live over at CosmoQuest. I am postdoc there. Noisyastronomer.com is my website. You can get links to all the stuff I do on Discovery, on Skeptic, on CosmoQuest, on all the internets.
Awesome. Dr. Pamela Gay.
You can find me at CosmoQuest and at starstrider.com. And I am going to leave with a parting shot of a image of the Ursa Minor dwarf spheroidal galaxy.
Ooh.
Where the galaxy spans the diagonal of this image and you can't see it. Because it's pretty much a
so hard to
see-through
find.
galaxy.
Wow.
Yeah, there's a large dwarf galaxy group at University of Virginia where I went to grad school, and they are involved in discovering these and mapping them and mapping all the tidal streams of the stars and stuff. So they're really amazing systems, even though they're so little.
Yeah, this is an image I took. It goes down to about 24th magnitude and slight overdensity of faint stars cutting from mid-upper left to lower right. That's the Ursa Minor dwarf spheroidal galaxy.
Oh, it's so pretty.
That's awesome. So what is next? I guess it's the virtual star party on Sunday night.
Party on Sunday.
And then we're going to be recording an episode of Astronomy Cast on Monday, and you should choose a topic, Pamela.
Yeah, it hasn't happened yet.
Episode 301, topic unknown.
Now, I'm going to be gone next Friday, so...
Wait, we still have Wednesday. Wednesday is the Learning Space Hangout.
Right.
We are talking with Jake Knoll-Storr of the RIT Insight Lab about topic of his choosing because we love him and we'll let him talk about whatever he wants. So it'll be astronomy outreach of some sort.
Awesome. And I don't know what you guys are going to do next Friday, because I'm going to be at Google I.O. next week.
Well,
We're
you know,
jealous
we
of
can
you.
hold down the fort.
All right.
We're going to be jealous of you. That's what we're
Yeah.
going to do.
Yeah,
Yep.
exactly. So,
think I'm
but if
around.
anyone's going to be at Google I.O., be glad to hang out with you. So, just
Oh, I'm going to be in Charlottesville next week. I'll call in from my hotel room or something. Or
perfect.
I'll hold down the fort.
Okay.
All right. Well, thanks everyone for watching. Thanks everyone for participating in the Hangout, and we will see you all next week.
Sounds good.
All right.
See you
Bye,
later.
everybody.
Take it easy.
Suspected. We've got a sort of an update on the annular solar eclipse that just happened yesterday, an update on a gamma ray burst that's been observed by amateurs, the upcoming conjunction that we'll be able to see, a recent launch from a Vega rocket with a bunch of satellites, white dwarfs with planet pollution, and new observations of hydrogen clouds between galaxies. So, well, let's start with the sort of breaking news right now. And I think, Nancy, you've been...
Comets.
Oh, yeah, the comets, of course. Whew. So many things to think about. Okay, so if you want to join the conversation, you can do that. And so all you need to do is just make a comment anywhere on Google+. There's a bunch of places you can do this. You can comment on the event page.
One of them is leaking, and although they don't know it for sure, they think it's one of the pump and flow control systems for the solar arrays that's leaking. It was a problem actually for a couple of years. It was first a very small leak was noticed back in 2007, and just back in this past fall, there was an EVA to go out and fix that, and 2 astronauts did go out and they did some replacements of parts and exchanging out of various pieces, and it seemed to be fixed. But now all of a sudden, they noticed this huge leak yesterday. So while the crew is not in danger, it's the space station really needs.
So we'll be able to spot your comments there. If you're watching this sort of on Nicole's stream or on the CosmoQuest stream or on my stream, you can post a comment there. If you're watching this embedded somewhere and you like to use Twitter, you can use the hashtag Space Hangout. And the kind of the safest place is to make your comment over on YouTube. So if you're watching this anywhere, click on the little watch this on YouTube link, and then you'll go to YouTube, and then there'll be a bunch of comments there, and that will sort of pretty safely make sure that we're able to see your comments. So, and we'll be watching those comments and adding your questions and comments and feedback as we go through the show. So, all right. So, Nancy, can you give us an update on what is going on with the International Space Station?
Yesterday morning, the crew noticed some white flakes of stuff coming off of the station, and in particular the P6 truss area, and so NASA quickly got all the cameras pointed at that area and everything, and so they determined it's likely an ammonia leak, and ammonia is used for a coolant. All the solar arrays, and there's the power is converted to, or the sun's power is converted to electricity, and basically this all needs to be cooled off, and the power is, there's 8 different power channels that take all the energy from the sun and distribute it among the different space station, everything that's running the space station, running the experiments, everything like that. And anyway.
So hi everyone, my name is Fraser Kane. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, May 10th. Host. There she is. All right. Let's hope that didn't break anything. So we've got Dave joining us this week. We've got Dave Dickinson.
Hey.
We've got Nancy Atkinson. There she is. We've got now the unnamed Nicole Gallucci. There, she's back.
Look, it's back. It's purple.
It's back. It's
me.
back. And Dr. Nicole Gallucci, and we've got Dr. Pamela Gay. So we've got a bunch of stories to talk about this week, and we've also got sort of a big breaking story that's going on right now, which is a coolant leak on the International Space Station that appears to be a little more serious than originally